So in the previous video called Tyflow Basics 1, what we created was we gave the particles the geometry of maple leaves, and we were sort of imitating how leaves fall from a certain height during autumn season. Let's try something a little more interesting in this one. So we'll just quickly set up our Tyflow, open the editor and set a few of the basic parameters, just repeating a couple of the steps from the previous video. However, we're going to add a few more things a bit later which will make the actual difference. So we select birding particles and the position icon, and then go to helpers, and under Tyflow we should find the tie icon. Let's use that, and after that what we're going to do is give some speed to the particles. So the number of particles being birded, we're going to change this a bit later. The position icon, just pick and select this, so the particles are being born within the specified space, and then we're going to give some speed to the particles. There it is. So the direction is once again set at random. We'll just choose the icon arrow. Let's just reverse it, because what we're trying to achieve is we're going to have a certain geometry of particles shoot up in the air and then fall back onto the base. And when they fall, when they hit the ground, they break into pieces. So we'll just pick the arrow and let's just reverse it. And we need to give a certain shape to the particles, just like before. And let's make them bigger. 100% is a bit too small. 3D. Let's think what kind of shape would be very interesting to watch break into pieces as they shoot up in the sky and fall back. Leaves would be a bit inappropriate for it, so in this instance let's just use cube. We have to go back to display again, change the geometry type, and you'll notice that they're going up at a very slow speed. So that doesn't look very appropriate. It will be in very slow motion. So what we're going to do is go back to speed and increase the magnitude. Let's say by 15. Let's see how that is. Yeah, that's reasonably fast, maybe a bit too fast. Maybe just make it 9. Yep, that looks reasonable. And maybe also increase the divergence to 10. So what this does is it's basically a sort of mechanism to make the particles lighter so they can rise up faster. However, there's too many of them and it's looking a bit clumsy. So just go back to birth and just put a specific number of particles per frame. So let's just put 5 per frame. So once, yep, this should be all right. So now we're going to use a physics shape operator which will enable these particles to move upwards. So we select physics shape, put it under shape, and there's a lot of parameters under here which we can play with. What restitution means, it's basically a more fancier word for bounce. And if I just increase it to 5, so Now you can see the particles are bouncing. Maybe I will increase the restitution to 10 so they bounce up higher, which will make sense. When they're falling from a higher height, they're breaking into pieces. Yeah, that should be fine. And another operator that we want to add so that when these particles go up and fall back, they break, is the Voronoi fracture. And as the name suggests, what that does is it breaks the particles when they hit a surface. So you select Voronoi fracture, place it under physics shape. So once again, one thing to point out is, as I mentioned in the previous video, how the system reads the operators according to the order from top to bottom. In this instance, this should make sense how it's supposed to bird particles, then move them along a specified surface with a specified speed, and they have a shape, the particles have a shape, and because of the physics operator, and I have selected the restitution so that knows that it's gonna have to make the particles bounce, and when the particles hit the surface back, they break into pieces. So let's find out if our operator arrangement has worked by moving the timeline. So you see the particles going up and they're breaking either when they're hitting the ground or when they're touching each other. So with any kind of physical contact, the particles are breaking into pieces.